Okay guys, welcome to the first part of the module 19.6. We're talking about solving trig equations algebraically today. I'm also going to build in the graphical portion so we can actually see the connection between the two. So we're going to be solving quadratic equation algebraically, and we're going to be tying in the previous knowledge we have on the characteristics of the trig function and how to verify our solutions from there. Okay, so let's move on. So here's the first example. Okay. Anytime you're solving, it's kind of like the same idea as solving for exponential and log. You really want to try to isolate the cosine x or sine x or tangent x or cosecant, secant, cotangent by itself, the way it is. So we're going to go ahead and isolate cosine of x by doing a little algebra here. So cosine of x equals to 1 over 8. The next thing we have to think about is, wait, do we know any particular special right triangle that has a trig ratio of 1/8? And the answer is no. So on this particular question, I'm going to require a scientific calculator to solve this. Okay. Now, before I do that, I do have to write this back into the exact answer, which then I can put into the calculator. So remember, to take this, to isolate x, I have to go to the inverse function, okay, which is inverse cosine. Oops. And in inverse, I'm going to have to flip my domain range, which means the 1/8 is supposed to go after my arc cosine, and the x will be here by itself. When I do that, I actually have the exact answer. So now I'm going to need a scientific calculator to figure out what the approximate answer is going to be. Keep in mind, it is an approximate answer, so we have to use the approximate sign. Again, let me make these slightly bigger. Okay, so x is going to be approximately, for those of you who are using your scientific calculator, you're going to get 1.445. Okay, so it looks like from what we're seeing is we're done, because I have my approximate answer, I have my exact answer, but the problem is, okay, the original question, a cosine x minus 1, when I say a cosine x minus 1 equals to 0, you're talking about finding the x-intercept, or the zeros, of the function of y equals to a cosine of x minus 1. Now, if we remember what a cosine graph looks like, minus 1, it looks like something like this. So let me rephrase my domain. I'm going to go from negative 2 pi to 2 pi, which gives me a total of 2 periods. Now, there is no phase shift, so the one period of this particular graph still starts at 0. The other one still ends at 2 pi. I really need to change this to pi over 2. Hold on. Okay, better. So if I look for x-intercepts within that domain, within that one period, there's actually 2. There's 1 here and there's 1 here. But the question becomes, wait, how do I find the second point when I only have the first point? Well, let's go back to the basics, which is, let's go back to a unit circle. Okay. Oops. Let's go back to the unit circle. So, if we remember, the unit circles are brought into 4 quadrants. This is the theta equals to 0, this is theta equals to pi, and this is theta equals to pi over 2. Now, pi is about 3.14, okay, in radian. Now, 1.445 is actually an angle smaller than half of that. That means the theta I'm looking for, okay, is in the first quadrant. So 1.445 is this angle in center position, okay, right here within the first quadrant. It's probably closer to pi over 2 than it is to pi, because 1.445, 3.14, if you think about it, it's about 1.57. So in radians, so this is probably closer to pi over 2 than it is to theta equals to 0. But regardless, there is my angle of 1.445. Now, cosine is both positive in the first quadrant and it's also positive in the fourth quadrant. In order for two of the thetas to share the same trig ratio, they have to have the same reference angle. That means in the fourth quadrant, okay, in the fourth quadrant, I have an angle called negative 1.445. And when I take the cosine of that angle, I will also get 1/8. Okay, so that means there's actually two solutions here. There's one at positive 1.445 and there's one at negative 1.445. Now some people ask my goal, but Ms. Zhang, how come my calculator didn't tell me? Because when you're using your calculator to do the inverse cosine of 1 over a, you are restricted by the function, by the range of the inverse cosine, which only goes from 0 to pi. So your calculator is only going to tell you the answer that's within the first two quadrants. But since my original question was a cosine of x, which means the original question, the context of the question is talking about y equals to cosine x, which the domain is all real numbers. Which means, and it's true if you look at the graph of this, is you have more than those two solutions. You actually have solutions that goes over and over again. In fact, if I zoom out, I have infinite many x-intercepts according to what I'm seeing graphically. Okay? So then how do we state that? Because right now I only have two solutions. How do I state the rest of the solution? Well, let's think. Within one period, okay, one period of this particular graph, you have two x-intercepts. So how do I go from this one to this next one? What is the distance between this point to this point? Well, that's one period of the graph, which is 2 pi. So going back, I can revise my answer again. Well, this time I'm going to write it separately. Okay, so Control C, Control V. I'm going to say it's actually x equals to 1.445 plus, again, okay, plus what? Plus multiples of pi, 2 pi, because the period for this particular function is 2 pi. Okay, and this will cover, and also one more thing though, but we have to state, and n is a what? Element of integers. Okay, and then I have a second line where it says x, okay, is approximately, because this 1.445 plus 2n pi only covers that first point right here and all the points that are 2 pi away from there. The distance between these two here are not equal. Okay, just like the distance between these two here are not equal either. So this point plus 2n pi will give me all the points that are kind of within that first, the beginning of the period. So it's all these. Or if I go minus 2 pi, it will be these. But I would need a second equation to justify all of these other solutions which are towards the back of the period. Okay, so it's going to be negative 1.44 pi plus 2n pi and n is a element of integers. Okay, I don't know why this is so big. Let me see. Oh, here it is. Okay, so that right there will actually cover all the solutions. Infinitely many x-intercepts that we see right here. Okay? Okay, so going back, let's do the second one. So second one is actually really similar to the first question. So what I'm going to do is same thing. I'm going to do another insert here. I'm going to isolate my tangent first. Actually, let me just borrow one of these here. Okay. So instead of saying cosine, I'm going to change this to tangent. And again, tangent of x equals to negative 2. Now, do we know any special right triangle ratios? The answer is probably still no. Okay, so which means I'm still going to be using my calculator for this. So I'm going to be changing this to, okay, the inverse, which is the inverse tangent of negative 2, which is equal to x. Perfect. Okay, there's my exact answer. I'm going to also need a calculator for this. So we're going to put this into your calculator. Again, make sure you're in the right mode. You're not doing degrees. You're doing radian. Not tangent either. Okay, so x is going to be roughly, give me a minute. Oh, where did my calculator go? My calculator has disappeared. Okay. Inverse tangent of negative 2, which is negative 1.107. Okay. Now let's think about this particular graph. 4 tangent x plus 8. What does that look like if I were to graph it? Well, let's graph it. So 4 tangent x plus 8. Now, if you think about this, the actual original parent function, which has a vertical asymptote at negative pi over 2 to pi over 2, that didn't change. So the period didn't change. You pretty much did a vertical stretch, and then you shifted up the graph 8. So within one period, how many times does the tangent graph touch the x-axis? And the answer is 1 time. It only touches it 1 time between any two given vertical asymptote, which is 1 period, from negative pi over 2 to pi over 2, or pi over 2 to 3 pi over 2, or 3 pi over 2 to 5 pi over 2. You guys get the idea here. You see that graph will only touch the x-axis once, which means to find all the infinite x-intercept that I see here, the only thing I need to do is basically says, instead of adding 2n pi, because the period of tangent is not, instead of adding 2n pi, because the period of the tangent is not 2 pi. What is the period of the tangent? It's pi. So we're going to just be adding n pi, okay? And then we're going to say n is a element of, you guessed it, integers. Okay, and that will cover all the solutions that we see, which satisfies the question here. State any solution that applies. Okay, so I'm going to pause the video here, and I'll pick up the rest of the video on the rest of the example on the next video. Make sure you ask questions, guys. Thank you.